All right, this is going to be a video on simplifying radicals. We've had a lot of people kind of in and out the past few days, so I wanted to make sure to get this made and uploaded so you guys don't miss a big chunk of kind of what's going to lead us into the next topic that we start covering. But simplifying radicals, we've been working a lot the past few days on square roots and cube roots, and so this is another way we can solve those problems without estimating them. So the title says simplifying radicals. We haven't really used that terminology yet, but a radical is anything that involves a root. Square root, cube root, fourth root, fifth root, any of that. Now, we've only been working with square roots and cube roots. So we've been looking at problems like square root of 49, which would be 7, because 7 times 7 is 49. You're looking for what number times itself gives you 49. We also looked at cube roots, where you had the little 3 for the cube root up there. Same concept, but now you're multiplying a number by itself 3 times. So if we did the cube root of 125, that would be equal to 5, because 5 times 5 times 5 equals 125. Now, we started out with perfect squares and perfect cubes like these two, and then we got into dealing with ones that were not perfect cubes or perfect squares. So we may have had the square root of, let's say 18, okay? And part of what we did was we first figured out, okay, what two whole numbers would that fall in between? And I know just below it you have the square root of 16, which would be 4. And above it you have the square root of 25, which would be 5. So we threw those in there. 4 is less than the square root of 18, which is less than 5. So if you were to solve this square root of 18, it would fall somewhere in between 4 and 5. We also noticed that it would actually be closer to 4 because 18 is closer to 16 than it is to 25. So we rounded them that way, rounded them to whole numbers. We picked the two whole numbers that it was in between. Now what we're doing in this video is we're going to be simplifying them. So we're not rounding them, we're not solving them, we are simplifying them. So the easiest way I think to show you how to do this or explain how to do it is just to jump in and do some examples. So last week, I believe sometime, we made a kind of a cheat sheet of all of your perfect squares. That's going to come in really, really handy when you're working these out. So let's say you have the square root of 8. We're going to start off real small, real simple. That is not a perfect square, meaning there is no whole number, no integer that you can multiply by itself and get 8. Okay, so what I want to try to figure out is, okay, what can I multiply together to get 8, but yet I want one of those factors to be a perfect square? Well, I automatically go, and I'm sure you do too, with 8, that's 4 times 2. So I can actually break this apart into the square root of 4 times the square root of 2. That means the exact same thing. But now I can solve the square root of 4 is just 2, because 2 times 2 is 4. I still have this times the square root of 2. I can't really do anything with that. It's not a perfect square, so I'm just going to leave it like that. And as you write your final answer, you can just, you know how we say 2 times x is the same thing as just 2x? Same concept here. 2 times the square root of 2, you can just run those together, and it becomes 2 root 2. And that would be your answer. That is it simplified as far as it can get. We didn't actually solve it. We didn't round it. We just simplified it. Okay? Now let's look at another one. Let's say we had the square root of 50. Okay? It's not a perfect square. I know square root of 49 is 7, so I know it's going to be a little more than 7 if I was going to estimate it. But we're going to simplify this. So let's break it apart. What can we multiply together to get 50? Now, I automatically think 10 and 5. But if I try to break this apart, square root of 10 times the square root of 5, neither one of those are perfect squares. So that really did nothing to help me. You want to try to find things that you multiply together to get 50, but one of them has to be a perfect square. So 10 and 50 didn't work. Next thing I jump to is 25 times 2. I know 25 is a perfect square. So I'm going to break this down into the square root of 25 times the square root of 2. The square root of 25 is 5. And the square root of 2, I just leave as the square root of 2. I can't do anything else with it. The only thing you multiply to get 2 is 1 times 2, so I can't simplify that any further. Okay? Now I do want to show you another way that I write these sometimes. Instead of separating these out into two separate radicals here, sometimes I will just write it all under one like this. Break it apart like that, and then realize that I can solve this part. The square root of 25 is 5, and I just bring that to the outside. That's how I'm going to do the rest of them, but I wanted to show you both ways to write it. So let's look at example 3. Let's say we have the square root of 175. Okay? Whenever I see a number like 175, I automatically think money. I automatically, in my head, go to $1.75. And then I jump to quarters. And I know $1.75, you can split that evenly between quarters. So I know 25 will go into it, and that's nice because 25 is a perfect square. So let's see here. I know I can break this into 25 times, well, let's see, $1.75, that would be 7 quarters. So that'd be 25 times 7. I can solve the 25. Square root of 25 is 5, so I'm going to bring that to the outside of the radical. The 7 will stay on the inside because it's not a perfect square. And I can't simplify that anymore. 7 is just 1 times 7, so I can't pull anything else out. There's my answer. Okay, the next one, let's do the square root of 108. Now this one may be a little more challenging for you, of finding a perfect square that goes into it. So if you want to pull out your calculator, you can. And just go through your list of perfect squares. We have 1, which isn't going to change anything. We have 4, because that's 2 squared. If I try to do 108 divided by 4, I get 27. So I could do 4 times 27. I'm going to actually show you a few different ways you can do this. Okay? If I keep going bigger, my next perfect square is 9. If I do 108 divided by 9, I would get 9 times 12. Okay? Let's see, the next one. Next perfect square would be 16. 108 divided by 16 doesn't go in evenly. 108 won't divide by 25 evenly. 108 divided by 36. I'm just going through my list of perfect squares. 36 times 3 would get me 108. Okay? So I'm actually going to work all 3 of these kind of simultaneously to show you that it really doesn't matter what factors you pick. You're going to end up with the same answer either way or any way you do it. Sometimes it'll take extra work, but you'll always arrive at the same answer. So let's look at the first one. 4 times 27. Perfect square is 4. Well, the square root of 4 is 2, so I'm going to bring that 2 to the outside. and then 27. Now, 27 is a rather large number. I know I'm going to see if I can break it down any further. I have 1 times 27, and then I have 9 times 3, and I know 9 is a perfect square, so here's what I'm going to do. I'm going to break this apart even further, okay? The square root of 9 is 3, so whenever I bring that out here, you're going to multiply that by the 2 that is already out front. 3 times 2 is 6. And then I have my square root of 3 still in there. And 3 is just 1 times 3. I can't go any further. So 6 root 3 is what we should end up with. And I'm going to show you that I'll get that on the other 2 as well. Okay, so let's look at the second one. 9 times 12. Well, 9 is the perfect square. Square root of 9 is 3, so I'm going to pull that 3 to the outside. Okay, now I have 12 in there, and there's a lot of different ways you can get 12, but keep in mind, I'm looking for factors that are perfect squares. So with 12, I'm going to come up here a little bit. 12, I know I have 2 times 6. But neither one of those are perfect squares, so that won't work. I have 3 times 4. I do know 4 is a perfect square. So let's go that route. Okay? The square root of 4 is 2, so I'm going to bring out a 2. And remember, since you already have a 3 out there, you want to multiply those together. And then I still have that square root of 3. And look, we got the exact same answer. Okay, and then let's look at the last one, 36 times 3. Well, I know 36 is a perfect square. The square root of 36 is 6, so I'm going to bring that to the outside. Still have my root 3 inside. And look, I got the exact same thing. Now, I got the same thing, but notice the first 2 times it took a little more to get there. You want to try to find the highest perfect square that will go into these numbers. It will shorten your process a lot. But if you don't, if you use a smaller one, it's okay. Just keep simplifying inside that radical until you can't simplify anymore. Okay? I'm going to do one more, and then hopefully you'll have enough examples to help you out. So the square root of 80. Okay, so I know 80, 10 times 8. I automatically go 10 times 8. But the problem with 10 times 8, neither one of those are perfect squares. So that doesn't work. Okay, it ends in a 0, so I know 5 will go into it. So let's see, 80 divided by 5 is 16. 16 is a perfect square. We'll break that down into 16 times 5. Square root of 16 is 4, so I'm going to pull that 4 out, and I have 5 left on the inside, and I can't break 5 down anymore. So 4 root 5 would be your answer. So this is simplifying radicals, not estimating them, not solving them, just simplifying them down. Hopefully it helps make a little more sense with what we've been doing in class.